Hello, dear friends. We're happy to welcome you at the live broadcast of АЛЛАТРА TV. And today, again, we have the Science in the Creative Society program live. Our guest today is an open, curious, and a very good person, Andrey Kazantsev. He's an accomplished junior researcher
а также преподаватель кафедры управления информационными системами и цифровой инфраструктурой Национального исследовательского университета Высшей школы экономии. Мы рады вас видеть, Андрей. Здравствуйте.
Здравствуйте, Светлана. Всех приветствую, приветствую наших зрителей.
Спасибо. Также в нашей беседе будут участвовать участники международного общественного движения АЛЛАТРА Наташа,
Здравствуйте.
Владимир,
Здравствуйте.
Захар,
а также Светлана.
Здравствуйте. Мы очень рады, что мы так вместе сегодня собрались. И еще хотелось бы рассказать и сказать, что сегодняшнюю беседу будут переводить переводчики на 5 языков: английский, французский, чешский, румынский, украинский. И сегодня мы поговорим о программировании в радиоастрономии. Также мы приглашаем наших телезрителей, чтобы они поучаствовали с нами в нашей беседе. Вы можете писать комментарии и задавать свои вопросы, которые мы озвучим и спросим Андрея в конце нашей передачи. Так что мы можем начать. И наш первый традиционный вопрос к Андрею. Расскажите, пожалуйста, как вы пришли в науку? Что было вдохновением, таким толчком, каким-то событием в вашей жизни, что привело к этому решению?
Ну, для меня все сложилось в большей степени случайно. Когда я был маленький, мама привела меня в книжный магазин и сказала: выбери то, что тебе интересно. Тогда я был, наверное, еще слабо понимал, что мне интересно, и, возможно, видя непонимание в моих глазах, продавщица посоветовала купить энциклопедию по астрономии, аргументировав это тем, что в ней большое количество красивых картинок. Книга была куплена. Сначала я смотрел эти самые картинки, потом начал читать то, что там было написано. Где-то годам к 10 я уже достаточно свободно ориентировался в ночном небе, то есть знал, где какие созвездия, наизусть знал гарвардскую классификацию звезд, даже понимал кое-что из физики. Но при этом, несмотря на мои такие возвышенные...
With all of that, with all of the interest that I had, I wasn't a really good student at school. When we came to the choice and like where to enter, which university to go to, I just wanted to have something as close to space as possible. Before that, I think it was rocket science. I just wanted to be, and I wanted to answer the rocket science department. But since I wasn't a good student in school, I didn't pass the physics. Unfortunately, I wasn't able to enter and enroll to rocket science. But for thing is, I was able to answer to the applied physics department, and there I actually understood that in reality this department is so much closer to the space than I've thought about the rocket science. And I entered there with bad grades, and I finished that department with all A's. On the second year of my studies, they have an observatory open where I started to work in, and so this was the bachelor's degree. Continuing for this the master's, and the astronomy I couldn't actually, and so I've decided where the place where I could do so, and so I found for myself that in Pusha the observatory or something. I've came here so that I've entered, enrolled, and from that moment of time, the work in science has started in more or less conscientious or with consciousness. So for the last 8 and 9 years, I work in science with what I was interested from the childhood and everything. Thank you so much, dear Andrey. And
А скажите, пожалуйста, мы
could you
знаем, что у вас
tell us, we do know that in the Pusha Radioastronomic Observatory, what exists is many areas of development. And what type of tests and studies do you directly participate in? Yes, we do have a big amount of different studies and areas of development. I take care of the studies of the gigantic, ginormous pulses of pulsars, which is the topic of my candidate's scientific paper. I develop an algorithms on the definition and clarification, astrometrical and physical parameters of new pulsars. Our observatory detects them, and I take care of the clarification their parameters, which is one of the most complicated topics that I have. I trying to get a hold of that for a long time, and I do work with the Svetlana Kramorosumana on the study of the pulsar B something something. This is the first pulsar that was detected by our observatory. When the pulsar was detected, this was the first pulsar was discovered by our observatory, and they started to open up and discover them one by one. Some projects I take care of myself, some take care of with other institutions as well. I wouldn't like to go in detail because there's so many of them, because in many projects I'm in one way or another are also enrolled. And during the first meeting, you told us this story that the person who was in school from your astrophysics, you get to the disease that the science is not only observation radio telescope. This is the giant work with data. Could you tell us in more of a detail what stages does the data processing take in? It was a bit different slightly because it's really I had a student like a scholar from school, and in some moment in time I've asked him, so like, what do you think about science? Because he passed a long way, and he said, wait, now I understand. It's not just the wonderful, nice pictures, and not just watching for the stars. And then you were right. It's a ginormous piece of work and analysis of the big data, working with those data, and you're trying to extrapolate a piece of information from the data. So everything else is like you mentioned. So the observers that think of them as observers and take care of observation part, their algorithms will work like that. So you just get the data from the telescope. On this stage, the data some way, somehow are being filtered. Afterwards, you can add like your own filters. So like if you think that this is like the decay or an outlier, or you're looking for an effect, so that you're just trying to extrapolate the data so that this is you. If you have the big masses of data, it's really hard to observe it with your eyes. So like with the files or something, you need the diagrams, you need the pictures, or if you have found out something later on, those pictures and those images and diagrams can get into your articles. In the scientific paper, this is the final stage of the scientist. So that the biggest minus that we have and the biggest point is that I don't like to write papers. So I love to work on data, and not only radio astronomical, but other types of data as well. But I just hate writing it down. So this is the algorithms that we have. And what is the most complicated part with working with the astrophysical data? The most complicated thing is an interesting question. From one point of view, I might say that the development of the algorithm itself, because you're trying to conquer the errors, because there is the code, there's an errors. You don't never know that whether you will be understood or something. So, but actually, it helps a lot if developed correctly. I would say it that way. I would put it that way. The most complicated part in working with data, with scientific data, is that you're working with the real hands-on nature. So, like, there were cases in histories when people think that it was the error or a bias, and it was the effect that they just filtered out all the time. And how to do the algorithm so that this, not to separate something interesting from what you have, this is an issue. So when you're trying to making a filtering, so you think that the pulse actually looks like that, but then the pulsar is actually bringing something completely different that looks completely in a different way. This is actually is one of the most complicated thing about our work. So how did you came to the understanding of how to do such an algorithm? Well, yes. I think personally that this is the neural network, machine learning, and it's possible. I think the specialists will tell me that some slight effects in neural network will be able to get loose and not capture, but then you just need to make an objective. And if it's they're doubting, so for them to give it to the like actual human specialist verdict, so that I won't have to look through everything for the whole mess of data, only in the separate points of things. So this is the solution for me so far. Something more accurate I haven't found so far. Thank you so much. We would actually like to ask you a few things in more in the detail on the piece of work that you're doing with the programming. As far as I understand, you were not a programmer before, but something made you start programming, right? And using the programming languages. And if the question is what made you do so, what inspired you to do so, which languages for programming actually do you use, and how do you what is the background behind the usage of the language? Just when I came into observatory, I was given an objective and the pack of programs or apps. So like, dear Andrey, here the program, you just press this, this is the result. You will tell us what happened there. For a student, this was the standardized objective, and you can't give them something really complicated from the beginning. So what happened was I've been working, and then I understood that first of all, I can't jump outside of the things that presented by the program. So whatever program is having, this is the only thing that I have, and that's it. And the program, for example, it wasn't, for example, each and every file you have to import separately, so that the programming and processing of the months of the few pulsars observation would take a few days, even though I would have to do manually look with my own eyes. I was tired as hell, and I couldn't add anything from myself. So I worked that for a long period of time. I think for 4 years probably. So I think it was enough. We've published papers. I've been in conferences, but I still felt like it was like a weakness inside. So I started to learn programming languages, and I started with Python, which is an answer to your next question, which languages I've used. I used Python because it was a good instrument. So like I had a good friend that recommended for me a good course. I've passed the course, and I've started to do such a home-based or home-sourced programming. I started to have different online courses, started to program slightly. Then I saw that yes, that finally came the time to use it in the practice and hands-on. And the program that was written down before that I was given, I've just taken it, I just rewritten it in Python, and all the things that I was doing for 4 years, I've gotten for in one day. It was such a small shock that why did I take care of that for 4 years if I could have started programming right away and using this program later on. And then I understood that I can actually broaden up the program. If I want a portion or a part, I can net it so that if I don't know, I just figured it out and I used it. So probably right now, if you people from science are actually looking at, nobody will be inspired that I've stayed in Python, because even though it has minor flaws that I know of and everybody else know of, it's a really rich language and it's really powerful. It's not a good programming word, but I still use it. So it's okay to use it with data analysis. A big amount of people actually do so, and also scientists and all. But apart from that, I also can let's just say if I will have a need for that, I can actually write down on C++. So if I'm trying to achieve something more complicated, I'm not able to process that, then I use for C++. So it's actually working well. So I know people that in their work they use in radio astronomy, they use the Cifratron, somebody use Java, somebody use C sharp, and they are in a minority. Mostly in astronomical radio astronomy, we use Python. And it's wonderful because when we are meeting up, the people from different countries or from different institutions, when we are speaking about data analysis, we understand each other pretty well because we are speaking the same language. And this is not in English or Russian or Ukrainian or whatever language. This is the data analysis language, which is done in Python. And as for right now, and frequently we have that discussion that why do we have it? Why is this? Why not C++? It's wonderful. I don't feel the need to move to different programming languages, especially taking into account that the most wonderful thing in Python is the ginormous amount of ready solutions in the library that you can use by scientists without getting deeply into details. There are libraries on the really specific task and objective, like a specific if it's possible. Even the radio astronomy, they are concerned as really specific. There are libraries, imagine libraries that really ease my life so much. And like just moving into another language, I just don't see why. Could you tell us about those libraries that you mentioned before? Are they available to all the scientists of the world, or everybody else just does their own lab or a library, or it's used in really small circles? So it's both ways. Unfortunately, it goes both ways because you can't really tell whether your lab or library will be useful for everybody. Somebody's just something developing something, researching an area, and then there's a person from a different lab, from different continent, for example, who does the same. And so they write down to each other. So I write out this part, and I have this part together. Let's join it up. And so they do so. And so with many years, it builds up and brings us to such a wonderful, ginormous project that will be used by everybody who takes care of this objective or task. So I can say a few projects that can be sometimes, unfortunately, programs that not go away from one lab. So just there's only one end user. So this is also happening, but it's a thing, yes. Andrey, I was listening you really closely, so what moved you to take into programming? You said that it was a weakness, so I just wanted to say maybe it wasn't weakness, maybe it was actually the feeling that I can do more, that I can actually explore more, and so radio astronomy and for people, for the society, and for my personal development, I can do more. Yeah, I think that you can also put it that way, because in that moment of time, let's not call it a weakness, but like it's a feeling of shame that you can't do more, that you are enclosed in the framework of one program or application. You can't influence it and you don't understand how it works. There was such a shame, but so I just really wanted to do more. So it makes the science actually makes you do and want more, because you have objectives in front of you that you go either do more or fast by just sitting for a few period of time. It might be a week, but like it will, trust me, it will pay off.
Спасибо, Андрей. А подскажи, пожалуйста, вот
Thank you, Andrei.
можно ли
Thank you.
сказать,
And
что
please tell us, so you've been telling us that astronomy uses very tiny degrees and very tiny dimensions, and scientists manage to do these calculations. And what's the accuracy of these calculations at the programs that you use, that you write, and how can you check the results of your calculations? How do you test the programs? How do you test the calculations? Could you please share us briefly about that? Well, speaking about astronomy, globally, they say that if a mistake is made by a degree, it's not a mistake. For example, if you make a mistake by 10 times, in the scale of the universe, your mistakes means nothing. Fortunately, maybe unfortunately, the situation has been far from it now. We are really from a different situation, because for some pulsars, the tasks require very accurate calculations. So 10 in the degree of -9 or -17, depending on the pulsar with which you're working. But it also depends on the project itself. For example, if you have some pulsar, or if you want to measure the flow, in this case, for you, it is not important the position of this impulse, so you throw more attention to determining this flow, and vice versa. If, for example, if you need the location of this impulse, you can give not so much attention to the accuracy of determining the flow. I would answer your question in the following way. We need accuracy, and we're trying to achieve such an accuracy so that it would be possible to research those effects which we are actually researching. Because if your accuracy is lower, is worse, simply you will not be able to see this effect. But if your accuracy is higher, why do you need excessive accuracy? You are seeing already what you're interested in seeing, what you want to see. So this is what it is. Regarding programming languages and computers, well, actually, this is programming languages deal with the level of accuracy that we require. And, for example, there can be two situations regarding verification. Well, I had a program I wrote myself. How do I check that I've written everything? The program must give similar results. It can be different, but not significantly. This is one thing, if you have something to compare with. And, for example, if you research something that has not been researched before, then you can check yourself, for example, by making sure that your results do not undermine the laws of physics. Well, you can also ask, like, what if we discover something completely new in physics? This can be, but you can need some pretext for new physics. If there's no pretext for new physics, then there is nothing to discuss. Besides, if your accuracy is insufficient, you will see nothing. If, for example, you have made a mistake, then I have already said, the main result of the scientist, of the researcher, is your article. If you write an article, you describe your algorithm, how you did it, with what data you've done it. And other researchers in the world may have this opportunity, and they use this opportunity to verify your results. For example, researchers from your own institute or from some other institute. And believe me, researchers are nice people, are kind people, but at the same time, they will also seize the opportunity to point out your mistake. And of course, if the researcher will not pay attention to the healthy criticism of his work, he's not a researcher. Because science is a big community, is an open community, and we must listen to each other because someone knows something more than you. And I believe, and I really hope, that all the articles that I have published have been read by my scientific head, and in case there were some mistakes, they have been mentioned to me.
And can we come back to the question, right? You said that we needed the preconditions, right? Actually, how do these discoveries occur, right? So actually, right, we have new knowledge coming to this world, but can we do without preconditions in physics? I'm just wondering.
Well, the clearest example of the new physics is transitioning from Newton mechanics to the theory of relativity of Einstein, as far as I believe. So people were living, and they lived the classic mechanics of Newton, and they were happy because it describes all the movements around them. But as soon as the speed increased of these movements, then an understanding came that at high speeds, the laws is a bit different, and classic mechanics cannot explain that. For example, if there is huge gravity, Mercury, for instance, his orbit does not work along the Kepler's laws. So there are some things that the ordinary mechanics cannot explain. And then the physicists thought, how can we not describe that? And then we tried to the need for another research came. So, and it was found by Albert Einstein. So it was special relativity theory and common relativity theory. Now this theory is enough to describe everything. And I can also move a little bit forward and say that everything has been described but we don't know what is happening inside the black holes. And this is the pretext for new physics. But people are still trying to understand this. They're coming up with new models, with new theories. As of now, we have no observations, we cannot confirm it. And we cannot say whether it is new physics or the same but something different. The same with dark matter. For instance, it was mentioned that the general mass of the galaxy was so for example so the dark matter does not emit any energy except for something along its object. What is it? Is it new particle? Maybe. Or maybe at big space scales gravity behaves in a different way. It is possible. We have no opportunity to verify it, but you can say it. What about modeling? And about modeling, you use the physics itself. You can use the classic model and then use your model or add your model. Maths is dangerous in such a way that it can show anything, but it cannot be real, it cannot be true. You need observations, you need theories, you need forecasts, and you need confirmations. And then the same thing again. So first, hypotheses, theories, forecasts, and so on.
So, right, we already have the pretexts, right? And there are a few of them.
So, of course, there are some prerequisites, the black hole and the dark matter, so-called. And continuing these topics, these discussions, we can say that all our knowledge about nature is approximate modeling that is based on observations and thoughts and conclusions of scientists. And getting ready for the program, we were thinking about the fact that all matter, living and non-living matter, from simple cells to huge constellations of stars, everything develops along certain laws and algorithms. So if we have a look at a simple grain, then in certain external conditions, the information that is stored in its genes, it leads to the fact that a huge plant develops, and this happens due to different chemical reactions. Also, this process can be observed based on the gene of the human being, of animals, and I believe that similar to that, the modern program works. It's just that the code is stored now as zeros and ones. So from this philosophical perspective, if we look at the situation from this, can we conclude that the law itself, the laws of nature, has some programming stored in it? So what thoughts or what ideas do you have about that? Well, you have actually taken two of such things that are very similar to each other, so programming code and our DNA. Yes, we have the information molecule inside of us, and we have a mechanism inside of us to read this information, to copy this information, to broadcast it further. And now the internet and literature has such terms as genetic code or deciphering genome, and I believe that the notion of genetic programming is still very close, We have some pretexts towards that, but I believe as far as this goes, similarities end, because if we take black holes, they don't have genome, they don't have genetic information, although actually let's not take black holes because we don't know what's inside black hole. Let's take pulsars. I'm an expert in pulsars. So pulsars have no DNA, they have no genetic information, and their behavior is determined by the laws of physics. And laws of physics are interpreted by a model. There's a standard model that interprets them. So there are small number of particles that form everything that we see around us. Yes, they have certain behavior, but can you call it programming actually? Well, actually, so there is this program, there's this model called the model of strings. So it means that there is an elementary particle, an elementary that cannot be divided further. Let's call them quarks. There are 6 types of them, 2 types along 3 generations. So these 3 units, and it is believed, according to this model, that inside themselves, although they themselves represent a string that is waved in a certain way. And if you change these oscillations, then the particle changes itself. And one type of quark turns into a different one. So the lower quark becomes the higher quark, and so on. If you have this approach to the matter, then it is possible. Maybe there is such a notion as universe programming, when you can take some particles and change their behavior. So there is definitely such a thing as biological programming, but can you say that this programming is inherent in nature? I don't know. I wouldn't be so categorical. Yes, it does exist to a certain extent by living matter, the DNA, whether there is information or it is transmitted. This is just a real small percentage from the entire universe. If the string model is incorrect, then there is nothing for us to discuss. I would like to make one small clarification. For example, if you take all the experiments on genetic engineering, all of these experiments are done on mice and so on, and they have very little lifespan. So you can see how everything affects everything. But here, maybe the span of time is different and we just don't see everything. So maybe we also need to take into consideration the time factor answer. So, for instance, we can take the notion of the universe programming. A couple of million years passes. How can I verify it for myself? How do you see it should look? Objects will remain the same. The fact that a couple of quarks change for different quarks, it does not matter. It is not detected by our tools. If we can influence that, if we can create a tool and we can take an upper quark, do something with it, and it transitions into the lower quark, then we can speak about this. So to say, making some sort of quark constructor. So using energies to form and create particles, and you can create matter out of energy. Will this be programming? Yeah, maybe in a way you could call it programming. Yes.
Разве оно не по алгоритму складывается?
Is it followed along some program? So, for example, if we use a certain program to combine everything, do we use an algorithm in this way? Yeah, this is what I'm speaking about. It depends on what you mean by programming, by this term, because programming is all around us. You can speak about, for example, well, some cattle will be smarter than some people, and they will have some programs, some algorithms. Yes, they are algorithms. For instance, you take a stone and throw it. Is it an algorithm? Yes, it is an algorithm. Can you call it a program? I don't know. I'm not sure. I think that here we can differ, because I think a program is one thing, and for you it is something different.
I'm talking just in general.
Yes, algorithms will be everywhere. Algorithms for sure. For example, to have a black hole, you need to do certain actions. You need to, first of all, have a huge star, and this star must have all the thermal nuclear reactions up to ferrum. and the star must collapse under its own mass. The electron become protons, creating neutrino. Neutrino compress into each other. Neutrino cell is dispersed, and then we have the black hole. This is the algorithm. Is that a program? No. I think let's determine in the following way. Program is something that can be rewritten and it can be made to work in a different way. Can we rewrite the process of black hole formation and do something else? No, we cannot do it. We have no such possibilities. When we have these possibilities, let's hope that we will have it one day. Then we will come back to this question and we will discuss this matter with you.
But we do have the preconditions, right?
Yes, there is a new physics, and it's some of that is possible, and from your own words, right? Thank you so much for that.
Yeah, and you know, today it's there is such a popular direction in science as big data science, right? And especially popular in astronomy, right? And as information coming from the telescopes, it really has lots of just a big volume. So, do you use such a direction as big data science?
Вы сказали наука о больш... Did you say big data science?
Right.
As far as I know, this doesn't like there's not the term there's big data. This is just the big data itself, right? And there is the science about the data, right? Which is the analysis and the storage and visualization. Was trying to extrapolate data from or information from data. But what you mentioned is that if you were to take these two and get together, you might have the big data science. I don't think there's a definition like that, so I propose you to save it for the future, so that the people who would use it in future would actually pay for you for that. You're completely right that we have a ginormous amount of data, and usually this information is in great amounts, so that it's really correct to say that we are working with big data. And then we do the analysis, we're trying to extrapolate causality. So it's really the data science, really. So if you would take this the tree of programming, who does the design, who does something else, who administers something, and there is also data scientist, so that the scientist who takes care of all the data, I feel like I can be more affiliated to them rather than to somebody else who is just a regular programmer. And in this moment of time, usually mostly the shamani was the science of big data, right? So there was an ginormous amount of them, the objects, so that the person was, it's hard for a human being to work on them, but right now it's just a collapse and a crisis. Because daily, all of the telescope that works, they receive data in much bigger amount that we are able to work on in that specific day. So what happens is observatories are working by just taking the whips of the cream. So they just get in the data, they extrapolated just a small thing or something interesting. So they are just making it to the network, to the servers or something else, or was the access by the logging. It's really easy to get those logging. For people from other observatories who don't have the telescope or any who's willing to do so because a person like to study the space and everything. So and it's all done for them. The biggest amount of people will be able to work on this data to see something, to get something, so that this data would not be lost. And this is not only the case in our country. It's in every lab or observatory. At least I remember one case when I was really afraid to write in the observatory. I have a big letter that I am like a young scientist, blah blah blah. I'd really like to work with your data. Could you please? I'm ready to give you all the data about myself, all the documents that you need, that I'm really a scientist. They just send me a login and password. They really didn't care. They're just happy that somebody else will work with their data. So yes, the big data science is that what we have right now. Can we clarify something? So you mentioned the big data, right? And data science. What are the algorithms? Maybe on such a easy associate example so that the viewers would understand. Then what is the algorithms that are used there? And maybe you can explain to extrapolate something from interesting from there. Okay, so what I meant was if we are to like generalize what all the observatories in the world would get, so that would be the intensivity depending on the coordinates in this space or depending on the time, right? Or depending on the frequency of observations. I think the colleagues will say that those are the main moments that are important. And you need to dig something out of that. You just need to have the variation in time. How this object changed during some periods of time, like in a year or something, right? The first thing you need to find it. Do you know its direct coordinates? Then yes, then you're building the program in the way that it finds this object in data. What do you want to do with them? So the brightness of one spot or the whole area or a specific area. So then you're writing algorithms in that way that it actually looks for a specific area in space. So that what do you want to do? So do you want to have the definition or the distance to something specific? You're just looking according to your objective. You're just getting only that information and visualize it. So like this is just a ginormous amount of data. You just take only this area with this area of time and just pick the numbers and everything of those dots. And this is what means, as far as I understand the question, what means to dig out the data. So the data might be different and interesting. So there's the pulses with the specific form. Just want to find the ones that are have a different form. So you just actually have the form and everything. And regarding the algorithms, they can be any way you want it to be. What happens in the when you have the sorting of the algorithms, I just know the name of that. I don't really need the algorithms of sorting, but I actively use, for example, regression analysis. People in our lab use actually how it's called, the methods of the lowest squares. Oh no, the lowest squares. It's from the regression analysis. But the correlation stuff is more interesting. So mostly that what we use there just regular good old math. If you want to optimize something so that these things that are supposed to be used here, right? So you can't say exactly beforehand what you will actually need. So if I place the objective, so I sort of build it up in my head, so like the approximate algorithm that I would need, but later on you just sit down and look at it so that I need to extrapolate something that looks like that. So what kind of methods exist for that so far? On the form on intensity, maybe on the correlation with the templates. So I can't really say or add something specific on the methods that were used. I have the cross correlation, which I like the most.
Спасибо, Андрей.
Thank you so much, Andrey. Could you also mention, you told us today on the fact that radio astronomical observatories and radio astronomers, they receive a big amount of data, right? So that's just gigabytes, petabytes, and everything. What is the stage of automatization of the data analysis of those observations, especially in your studies? Right, I think I understood the question. I try to do as much autonomy and automatization as possible. Unfortunately, you won't be able to reach 100% at all, but like I'm trying to achieve it as much as possible to do so that I would be not involved or spend as less time as possible for any data processing parts. There's nothing extraordinary from that because I think that the program is actually working that you can the same thing you can actually do something else, write another program for different projects or solve like different issues or work on a different stage of the process or just write an article that I don't really like to do, so I don't really a frequent writer So if you ask me about the stage or the range of automatization, I would put it that way, from 50 to, let's be optimistic, to 80% of all of the things that I do, I have the automatization. I can also add the 5 more percent if, just in case, I will do the automatic like downloading or something else, so that the work directly on the server. But so far I don't see the need in that. But still, we have a small percentage where a person is still needed. At least you have to look, did the program find the thing that you needed or not? Or is the thing present in the space-time or it wasn't? Thank you so much for your answer. Dear Andre, you've mentioned before on the neural networks and everything, so that could you mention a few examples or like simple association or just in a common language, what is the artificial neural networks and how complicated that is, and how is it connected to math probably? And together with that, could you make a few examples in your specific work that you use them? I would just like to answer, this is directly connected to math. Of course, all of the algorithms, all of the things are that implemented in the artificial neural networks, those are just the mathematical algorithms, so just the simplistic ones. So when you don't have a signal, the signal is still present, right? So this signal can be received because any conditions might be fulfilled. So you just are picking the matrix, I would call it that way. So just like a box, so to say. So that condition number 1, condition number 2, so like this, the second, third, or so depending on the number of needed conditions. And then you go on with the motor function, so the function that analyzes the a conclusion of what your machine has done. So is it yes or no? So, and you're adding conditions. If a condition was fulfilled, so then it was on. If it's not, it will be off. So that the end function will say yes or no. Was it fulfilled or not? So this is just in a more simplicity, in this, as much simplistic as possible. But this is the most initial element of the first neural network. Right now we have signoids and other parts, but those boxes are the initial parts, and then we have more algorithms. But how complicated is that? I will answer it that way. If you will get to the math and to dig into mathematics itself, it's not going to be easy. Even was not the worst education and the knowledge on the objective. I had problems in the implementation of the issue. But if you would actually go away from the math and you just take a concrete objective or topic, then the Python itself that I will actually making that of. They have the prepared packages that you can look at how tutorials are done. You can actually make your own neural network. It's actually mentioned, this is the data table. This is the, I usually use classificator or classifier, so I'll explain what it means actually. This object, another object, this third object. So you just put this, you put this here, you just launch this, and you get the result. This is as simple as that. The other point of things, that the work itself on the education of neural network, because it has to learn, they need to know which conditions are actually meaningful, where to look at, and what to look for. It has to study and work for that. You need to give them a selection of data. Then you need to prepare a selection of data to clean the data, to clean the outliers or errors or biases. So, or that are really different and that would spoil the scientific work that you have. So, and this is additional science. And even now, we have a number of libraries that do so instead of a human. Getting back to the thing that how usable that is for me. A few months ago, I was placed with an objective to renew the classification on the to distort or to separate pulses and errors or biases. The standard algorithms were not able to do so. There were still errors or biases that was still present. I went for that one time, and there was this constant re-evaluation. So we did something, we got something new, we add something else to that as well. And so for a few times I worked on that masses of data, I was trying to separate it. So the post there, errors there. Then I understood that it's not really nice to do. It's not really serious for a data scientist, right? So, and I do so, and I do things like that. So I was prepared, so I knew that neural networks, I read a few things about that, and I understood that the time has come and I can proceed, and I've started to create a really simple classifier, and it worked actually faster, much faster than I did. And it's much better than that, but I wasn't ready for that really. So yes, I do use it, and the more you go deep, the bigger the usage. So right now it's a really popular thing. The number of presentation and scientific papers are really dedicated to the fact that really, look, we've took all data, trained the neural networks on them, and look at what we got. Completely new results, completely much better things that we have. And plus, a few years ago, people are started to continue with the old archives. And between all of the astronomic groups of people that we have old collections and archives, and that were under the entropy and outdating processes, and people started to digitalize them, found something new. It was such a wonderful that we can find digital algorithms, and then they trained neural networks and they found something else, something better, something new. So yes, this is the popular topic. We're trying not to be lacking behind or falling behind of them.
Thank you.
And I'd like to go on with the topic of neural networks and artificial intelligence, right? I would like to tell you about the unique development of the company and XP Energy, right? These are the first creators in the world, are the first creators of the artificial consciousness, right? But in contrast to artificial intelligence, right? Artificial intelligence, it is limited, and artificial consciousness, it's been created on the analog of with the just a person's consciousness, right? And this unique knowledge would be really just great if we could apply it for different directions in science, and it could bring up great results. We could really go further in the study of a person, and the answer as like the universe was formed, right? Just new directions in science would be possible to develop using this new knowledge, right? And especially for the programmers, this information is really unique because it is exactly the programmers who are able to understand what is a true quantum computer, right? And what can and even can be multidimensional or multivariable programming, right?
Multidimensional.
Right, multidimensional. So that is why I suggest right now our technical support to switch on an episode from this new program, XP Energy.
And now, thank God, we have artificial consciousness. It consists of two typical and two the four typical blocks are, guys, well, how do I explain it? This is something that forms our character, our nature, and so on, and what we call primary consciousness. The main block, it is what appears to be the observer, where we store what we call conscience. So what does a neuron send? Simply just 1011?
What?
Or information? So what do? This is the main difference. And we were struggling for a long time, and then we came to an understanding. What's the difference between a simple computer, between its bit and a neural impulse that moves from one neuron to another? So this little neuron in the head sends out merely not just an impulse, but a filled impulse. You see? Yes, something that is filled with specific information. What is going on with computer? We run empty rail cars. Jumping ahead, I'd like to say actually quantum computers that work precisely on multi-dimensional programming. So they operate at a completely different approach. In reality, a quantum computer is something that is able to go beyond the limits and actually produce that something real.
So this artificial consciousness, there is a plan to demonstrate it, and what to do with it next? I mean, will it be the end of this project to create an artificial?
Well, simply how? Actually, we had an idea, and we wanted to show it somewhere at an international exhibition, to show it to people, to talk about the dangers of the artificial consciousness itself, as an idea to legally limit the development of it at the international level, strictly up to neurons.
Neural networks.
To develop neural networks only, but not to touch artificial consciousness. Why? Because there are huge risks there. Not everyone treats it with due responsibility and care. You can fail to restrain it. There may be problems. What for? No need for that. As long as our society is on the verge of consumerism and is itself on the verge, it is better to legislate it for now. I want to draw public attention to this. Watch more at Alatra TV.
Thank you. And another question to you, Andrey. If we come back to artificial intelligence, right? Which risks or perspectives do you see of developing this artificial intelligence?
Okay, just give me a second. I'm trying to process the video. So artificial intelligence is one of the top developments these days, and our civilization has reached the attempts of creating the artificial intelligence for multiple times. And actually the first article about perceptron, which I have mentioned, it has been really popular and controversial, and people were saying, look, a couple of years pass and we will have artificial housewives. I'm exaggerating, of course. None of this happened. And maybe the technologies back then and algorithms and methods and qualifications were insufficient in order to create something that complex. Today, we have some developments, and for example, if even I, a person who is prepared for this, I can be shaken by what some systems are capable of. But at the beginning, you said it very correctly, that artificial intelligence, some people, actually every person, understands something of their own by this. And if you draw a strict line, a strict borderline, then you can say that there is a strictly a strict artificial intelligence, a package of algorithms that is capable of solving a certain task, maybe one or two or three tasks. And outside this task, it is unable to go beyond. And creating such artificial intelligence is not a problem these days. It has already been created. And on the other side of this borderline, I can say the so-called global artificial intelligence, again, a package of algorithms that fully imitates our brain, our consciousness, and our functions, our possibilities, that is capable of learning, that is capable of acting upon the previous experience, although neural networks are teaching themselves as well based on the previous experience. But I hope that you can understand this difference. So there is this algorithm that we cannot discern from the brain of the human being. Where can the problems arise? Right now, we have nothing of the latter. No matter how many conferences or articles I read, I have not seen examples of such things. There is still a huge way ahead to the real brain. And maybe one of big problems is that we ourselves know not enough about our brain. So the way it functions, although neurobiologists dedicate a lot of time to that and they try to answer these questions. You asked about the perspectives and risks, yes? So perspectives, and I would like to hope that if there is sufficiently planned approach done by a lot of specialists, not just programmers, I'm speaking about engineers, neuroscientists, and maybe some other professions of the future, maybe, possibly, creating the global artificial intelligence, if we have such approach, it can be possible. Well, how likely is it to be created? I can say that the artificial intelligence that I imagine for myself will be much more capable of exploring space than we are. In other words, it will not be as dependent on the threats, it will not be as limited by the threats that space poses. It will not be as soft and fragile as the human being. Recently, at a training, I managed to hurt my leg and I was totally immobilized. And it would have been nice to transfer my consciousness into something that was much more sturdy. As far as risks go, I believe that as soon as this global intelligence is aware of itself consciously fully and reaches a certain level, it will destroy us. This is neither bad or good for me. This is a rather intelligent consequence. This is what I think. And probably the global task of the human being is to create such an intelligence, and we mustn't. So what I'm trying to say is that this is the creating a form of the universe that is aware of itself. So we are creating sort of something, and the universe is trying to understand itself. We're doing this in a very poor way. We understand not so many things. We cannot calculate many things in our hands. The artificial intelligence will be much better at it. And it means that at the competition market, at the healthy market, it will be much better. And the fact that we create this artificial intelligence, this is a good thing for us. This is what I believe.
Yes, thank you. And please, could you tell us also, we as the whole humanity, right, we have a great potential for the development, personal as well as just general, right? Development as the humanity. And can we, as you just said, can we use this artificial intelligence as the kind of instrument, tools, right, for just applying, if allegorically, figuratively speaking, can we use this artificial intelligence just to help us improve the conditions on our planet, right? To just like to plant the planet with different right plants or whatever. So can we use it as a tool so we would have everything in abundance, right? Do you just think it is possible?
You mean without artificial intelligence? Without artificial intelligence? Yes, of course. Okay, I realized that you did not hear me, so I will answer two of your questions. Can we do it without artificial intelligence? Yes, we can. And yes, truly, we are limiting ourselves potentially. I cannot say that. The human beings are capable of a lot, and recent situations, when, for example, when the American space program has become successful, these situations show us that we have received a new type of rockets that is launched beautifully, and they make the process much simpler and much less expensive. Maybe not simpler, but definitely less expensive, which means that more space explorations are closer to us. And if we take and if we stopped wasting a lot of resources at some wars we don't need, we can direct these resources towards making the desert a green place if this is required, because the desert has its own ecosystem with its own life, and who gave you the right to destroy this life? But at least we can direct these resources to clean the water reservoirs that we have ourselves destroyed or made dirty, polluted. We are destroying something, and we must allocate resources to fix the things that we have polluted. Why are we not doing it? So I have answered one point. Can we do it without artificial intelligence? Yes. Can we do it with artificial intelligence? Yes. But this artificial intelligence will maybe ask us, why have you been unable to do it earlier? Get away from this planet, and it will do everything on its own. This is some of my thoughts. I cannot say that this is what will happen.
Right, maybe I just, put this question not exactly, but all of us believed that science is being is done by people, right? So if, like, again, something appears, then it means that someone must have done it, have created it, right? So the same with the artificial intelligence, right? If a person is really if a person he's well brought up, right, and he really cares what is happening around him, right, what is happening in his country, he wants to live in peace with the whole world, and where the whole world is as one big family, right? So such discoveries, inventions, right, they would, why are they created, for what purpose? For us to help each other, right? So do you just accept such just hypothetically that there can be so that, right, we're talking about different issues in science, and but since people, they do these inventions, right? Right, as we have different information about what's been invented, right? And actually, where are these people who? Okay, we're kind of crazy about inventions of themselves, but what about people? Just a person. He's the main right focus who has carried out these experiments, right? So a human, right, does it all.
Yes, it was created by people. You are completely correct. Could you hear me right now? Yes, I do agree, and yes, the person creates it. But if we would get our previous discussion, we mentioned the artificial intelligence. Let us just imagine that the same me, but just who inside of himself has the artificial intelligence. Because of the bioengineering, they will have the same tissue, the same blood, just according to its development in blue script, but they make 1,000 times better than I do. Who would you take the interview, from me or from him? I think probably from him, because even if I've created him or it, they would still be better than I am. Then yes, when a person creates something, it's created by him, and he can create either a wonderful thing that would help people and get help to everybody. Also, he can create a wonderful thing that will be a nuclear weapon for humanity, and it can create an artificial intelligence that in the future for humanity will be a safe belt, or will relieve the planet Earth from a virus of itself, because we, as you and I, unfortunately for Earth, for the ecosystem, we are more or less like a parasite. But still, if we are really like would get it all together and we will think better with what we're trying to do with the programming, then in the end we are supposed to understand that we need to use more and rationally the resources that are given to us, because the space have a vast amount of resources and we are just trying to get it from our planet by and also by killing each other. I really hope that I've answered this question, or actually just mentioned what I was thinking mostly.
Я только добавлю,
All
что
right, I would just like to add, that I'm just I like taking it with from a human, right, not a machine.
Тут видите, какой
If there will be a
момент.
difference, that we can face the
Совсем
fact that we won't see the difference. You know, what's the thing? It will be just like I just in the detail I can only imagine it from right now in my head. The examples from cinema, like, and a person from another like 1,000 years, and I forgot how the name of the actor was. It wasn't understandable where was the person and where was a robot, because they've passed such a iteration and changes that in the end, I won't spoil if somebody didn't watch, please watch. He had a thing that he wished for. The question was that how did he end it? Did he end up as a robot or as a human being? And we can get into detail and to speak of that for a number of something those moments, but I'm most unsure, and I want to believe in the fact that this is our programmed idea continuation of our ideas and stimuli. So if you will create a robot vacuum cleaner that we have in most of apartments, it doesn't look like really it doesn't think about space at all. It's important for it to be clean in the house. We can create systems that will think of space, and they will take an objective to study the space. And if you know how to write the programs that write themselves of there, then we will have the most interesting part coming. Then it's not understandable where the program that written down will go. Getting back together on the universe programming, it will probably go according to like the laws of the universe. It will be written down that it's not gonna be able to survive or just destroy itself. If it's written down that they have an advantage, then the natural selection will go. So we all know, or that we came from the small cell and we've developed to wonderful creatures, right? That what we can do later on, the question still stands. But we can actually do something better than what we are right now.
программа, что вложил, то и получил.
Right, what you input, so that you get, right? But that's talking about a machine, but a human being, right, is more than a robot, right?
Различие, что
Yes, I think that we can discuss that again. We can discuss it for a very long time.
к следующему вопросу очень интересно.
All right, so let's move on with the next question.
We'd also like to ask you, we've touched so many wonderful topics today, like on the top layer in the society. Could you also tell us the role of the making science more popular? You mentioned it before, that making science popular is the important part of what you do in your everyday activities. Could you tell us about your experience? Yes, thank you so much for the question. When I came in Pushchino, I opened up for myself a capability for the Pusha, for example, observatory, where I started to work and work still. They had an astronomical extracurricular activity for kids, and there were kids and elderly people came in. Our scientific advisor mentioned about the space, what the observatory does, and so all of that issues around the program and around the space. And at some moment of time, I was proposed to give a lecture there, just a few of them, and I was interested by the process for a long period of time. Maybe for 4 years of my life I've actually dedicated to that, so that I've took care of that for 4 years. I've given lectures. And why is it good? Because children like small ones, they are probably one of the trickiest auditors because they're not afraid of everything. They're not afraid to ask you a question. And questions that they do, so you're telling a kid something and he doesn't understand and he starts to dig in. Why is it so? And why is it so that way? And why is it so that way? And so he gets to the moment and you're asking yourself, and why is that so? And you actually get to the point when you're in your head trying to answer and to say, I don't know, because it's not, you're not supposed to be afraid to be not knowing some things, and you just get back to your room and just trying to answer the question, why is that so? And so this framework of the astronomical extracurricular activity club, it began to come to me as the training field where I've trained myself to be a specialist that I am right now, getting the question that I didn't know the answer for. And so it raised my professional level drastically. Afterwards, inside of me, I had also for I made an excursion for children from different and elderly from different areas. So in one of the excitement that they had is to visit observatory, and it's also the type of audience that with specific needs. They're also not afraid of anything right now because they live for their whole life, and they have so many questions that they've gathered around. So and they are filled with wonderful TV channels or something else that we are afraid to mention. So it's not an advertisement in any way is possible. So you're also spending a lot of time, and you're trying to answer the questions to this to the consciousness that's filled with garbage was that TV channel was trying to portray, that the Nibiru planet, Anunnaki, like flat Earth or something else, or Atlantis or something else. And you're starting to work on that moment of time as well. And so you're trying to bring the goodness to the society. You understand the medium level of education in the country, and you're growing yourself as that as the professional and as a technical expertise. For the latest few years, I have myself started to, let's just put it that way, jointly, or we just need to mention there is the fund which is called the Fund of NGO Initiatives Trajectory. And I started to cooperate with this fund really fruitfully in the implementation of astrophysics school, which is a wonderful thing itself. So children that are in the 8th grade, 2 times a year, they are taking to as such a outside of school activities. And so starting from 8th grade to 11th grade, so there's in class and there's out class cooperation, and they're being brought to the observatory. There's in our countries, and it's actually abroad, and they're being taught that those kind of programs that even I envy those kids really, because this is something extraordinary. And the kids that get out of the school, they understand what is space actually, what is the work with data. And many of them actually understand that astrophysics is not the thing that they wanted. They don't go there. And it's also a good thing, because having that wonderful education, they're going in some other place, and they are making and creating something really wonderful. And some of them are staying, and they are more than ready than I was myself when I just got into astrophysics itself. And right now, I think that this is the most wonderful project, speaking about the promotion of science in the masses. I just trying to give a lecture or applied physics lecture or something, and to work with the Trajectory NGO Fund. I actually picked the work with Trajectory Fund that they have to choose, even though I'm always trying to give the time everywhere, but unfortunately we have the less and less time, and it's not my main um, area of work, so I spend only my personal time for that. So this is my actually area of development that I've been following lately.
Спасибо большое.
Thank you so much for that.
Ну, продолжим дальше. Мы
Let's move on, right? And now we are just coming to such topic as the creative society. You know that on the platform of ALLATRA International Public Movement, there is such a great project as the creative society, right? And all over the world, our participants are taking interviews from different people and asking them in what kind of society they would like to live, what kind of science, education, medicine should be in the creative society. And we'd also like to ask you, what would you answer? In what kind of society would you feel happy? And your family, your friends, in what kind of society? So just, without any kind of patterns of thinking or just used habits. And how would you imagine such a happy society?
I think for myself, I would just place it that way. That as for right now, the society that I would like to live in, it would be the society where every individual would have the active social mindset, and the violation of somebody's rights or rights of somebody else would be picked as the personal offense, and they would get out to protect those rights. As right now, as it mentioned before, peacefully with no ammo. This is the society where where there's a rule of law, the change of the government, a healthy market with the healthy competition on the market, and a society that is still not perfect but still understand that there are issues and are trying to change things, trying to correct things. This is, I think that this would be the most wanted place where I would really like to live in. The society that I am trying to grow inside of myself at first. And what is your role in this society? How do you see yourself? So trying to stand for my rights and rules.
We have, everything good in life, so to what should we strive?
If everything would be okay, then we just need to live and work, right? I just don't have anything else yet, but still preserving this society if it went that way. And if it's this wonderful, everybody would be support rights of themselves and rights of each other. You just have to live and work.
Yeah, and enjoy your work, right?
Right now, I'm still glad that I'm working, that my work is actually for many people that I still in the crisis, right? That in many people, they have the work is dedicated to the being present at a place. And so thank God it's not like that for me because and my wife has the same thing. So we are working just always, and I'm always at work, and I'm always happy to be at work. It's not always such bright and everything, but like I'm getting at work and everything else. I'm doing that and that and that. But that's a wonderful thing actually.
Thank you for your answers. And what do you think? How would radio astronomy would be developing in the creative society? Which task would you?
I think that I would just like to open the topic of creative society. What do you mean by that? What do you mean by that? I can say for myself, actually.
For me, creative society is the society of happy people, right? Where each person is happy. And according to our social polls all over the world, we've got the 8 foundations of the for building the creative society, which you can see right now on your screen, right? So the first foundation is human life, because we understand what is the most important is, of course, life of a person, right? It's the highest foundation. The second foundation is human freedom, because each person is already free since he is born, right? And no one can demand any rights or anything from a person. The third foundation is human safety. When we talk that no one can just endanger a person's life, right? And all, the conditions of work should be just directed towards human safety, as well as creation of artificial intelligence, right? Or any just technical means, right? They should be safe, first of all, for a person. And the fourth foundation, it should be transparency and openness of information for all. So the society itself, it should, or people actually themselves, they should direct and they should give this request for what kind of information they would like to just kind of to take. And the fifth foundation for the creative society is the creative ideology, right? So it is based on the moral issues. And the sixth foundation is the development of personality. I believe that this is a great foundation according to which any person should have this access to education, medicine, right, and to any kind of work that he wants to indulge in. And the most important thing in the creative society would be justice and equality, as according to the seventh foundation, right? And this foundation is self-governing society. So we are talking about that there is no power as such in the creative society, but each person contributes to the development of the society, right? So if we talk about the topic of the creative society, so these are the eight foundations for building such a happy society. And what do you think? If we just imagine that we already have this pretext for such a creative society, which text would it solve?
So let me answer your question first, and then I will go on some of your points for your reference in the future. So the question is, how will radio astronomy will develop in such a society? The question is, do we need radio astronomy in such a society? Thing is that science is an environment that is uncomfortable in itself. You're always uncomfortable. Something is heavy on you at all times. And if society needs that, society believes that, for example, we have a self-governance, and society decides if society develops radio astronomy, then everything develops, and I will work, and you will receive some of my rare articles. And if radio astronomy will not be needed to such society, and it is also possible, then I will have no work, and you don't need to be sad about it. I will find something for myself to do. You must not stop that. It must not stop you. And regarding what you said, well, I have a scientific approach, and probably the way I look at things is slightly critical. So I have a couple of questions for you. And so what I'm trying to say, let's not be anthropocentric. Guys, you have forgotten about animals because they have the same rights as we do. Yes, maybe they cannot run for the Senate, but they have the need for security, and we are responsible for their security. But what you have, guys, is quite anthropocentric. It is focused on human beings. Your limitation is just on creation, will limit science a lot, because biology in its form, in its basis, was about destruction for a long time, because you had to destroy something in order to understand how something works. You know, there is an example from nuclear physics when, for example, a professor had a board and he was explaining how an andron collider was working, he took something and threw it into this board. So he was destroying some particles and looked at how they were working, how they interact between each other. If you do not have destruction as such, you will limit physics a lot. And if we grow up to high level of development, I suggest you look at the scale of Kardashev, the development of civilization, and if we juggle the energies of the space, and if I will be the pulsar specialist of that time, you know what the first thing I will do? I will destroy a neutron star in parts and see what's inside. This is what it should be. This is how science works. But in your foundation, you have humanistic opinions and modes. And of course, I would like to agree with that. We must try to follow the path of creation, to try to create. Even if you destroy something, you must take these pieces that you've destroyed and create something new. This will be better then. And what about the rights of other people, the rights of aliens? How do you know we are the only sentient civilization in the universe? Actually, there are few chances that we are alone, and, for example, another being comes, it has no rights. Of course it does. Must it not have protection? It must have protection. If he wants to find employment at our Earth, he will need to do it. So this is something for you for the future to think about.
Thank you for your opinion.
Thank you, dear friends. Our TV broadcast is slowly coming to an end, but we would like to also read a few questions from our audience. Several questions. Andrei, if I may, I would like to read 3 questions to you. Question number 1. Do you have any joint projects with researchers in other observatories? Some volunteer projects. And what does this planned project give you if you plan this project? I hope you were able to understand this question. Actually, I did not. What do you mean, like, as volunteers? What I'm trying to say is that any cooperation in science always has some benefit. If you, for example, give some data, you hope that you will be included into the article or mentioned in some acknowledgements. If you take some algorithms, then most likely yes. And answering the question, yes, I have some joint projects with the colleagues from observatories in Russia and from colleagues from other observatories in the world. They aren't as many as I would have liked to, but still they are present. And sometimes it can be difficult to be friends with everyone and work with everyone. But as for volunteering, as for so selfless approach, we all of us understand that we have some interests. We want either to get some data or to be mentioned in an article. And actually, I did not hear the end of this question. Could you repeat it, please? So at the end of the question, there was, what gives more success? The project planned in an observatory or the project that came up as you talked in a friendly way with someone? So as far as I understand, the second part is maybe it was an initiative of scientists themselves and they decided to do something, to explore something, or this project as part of some international program. Answer, okay, I understand. And I think that in my experience, those projects that are local are more successful. Because this remote communication, we have all of it these days, but it actually gets in the way of the project developing quickly. For example, you write a letter to the person, he may read not now, but later, and he may reply later as well. So live communication makes the projects much more successful, but if you have some acumen, and I will not say that this will be a volunteer approach, but I don't want to insult anyone, but there is no such notion as amateur radio astronomy. There are some amateur astronomers, but for example, a person who's an amateur comes to radio astronomy and says, I'm an amateur, what can you recommend it? Of course, I can tell him, you can study things, but if he studies, he will focus on data processing, but then he'll become a programmer. What's important here is the professional approach. And when professional scientists come from big institutes, they actually can do something serious, but it will, of course, it will not be as successful as the projects implemented at the observatory itself. Thank you. Question number 2 is as follows. Do you create research tasks for yourself on your own while you program? Answer. Sometimes I create tasks for myself. Sometimes my scientific advisor or leader creates these tasks for me. Sometimes you read some article and you see that people have done something, and you think, yes, it would be nice to maybe verify it or check it or do something of your own. Or at other times, you just wake up in the morning and think, look, but this has not been done by anyone ever, and you just go out and do it. You try to do something. Thank you so much. Question number 3. So if, for example, if it is possible to program the artificial consciousness, then it means that someone has programmed the algorithms of our consciousness, consequently of the entire universe. What can you reply to this question? Answer. So basically, this is an anthropocentric approach, and it also means that the universe is such so that it is created for us to exist there. This is the observer's effect. This is the way you see it, actually. But getting back to my story about making science popular, so what is the main question? Let me ask you a question. In your opinion, what is the main question that older, that senior people ask? Actually, I don't know, to be honest. I'm still quite young. Maybe the question is there life on other planets? No, the question is there a creator? The question they ask, is there the creator? Does he exist? They call it in the normal way, but so our universe has been created by someone. It is difficult for people to believe that the universe has been created on its own. And how do you answer to people of senior age? Sometimes it can be difficult because it may not be easy to reply to this question. So the answer I have come up to myself is that we don't know. The universe around us works along certain laws that has been specifically determined. You can call them programs, these laws, but inside our universe, there is no creator. If the creator exists, he's probably outside our universe. He created this somehow. He has somehow set up everything, and now it lives without his knowledge. But if he has done all of this, if he has set this whole thing up, then he would probably understand such things in the good way, such as math, physics, astrophysics, and programming, then he would be my colleague than to any of the priests on this planet. So actually, it's difficult for me to answer to your question whether we can program something and create artificial consciousness. It means that someone has programmed us, someone created us. You know, sometimes I want to think that our universe is someone's failed thesis, PhD thesis. So it's like an extraterrestrial civilization that is capable of creating different civilizations, and some other extraterrestrial civilizations are better at creating civilizations. So actually, you cannot speak about extraterrestrial, but you can answer yes, you can answer no, but not a single answer will provide you with evidence that this is so. So unfortunately, I have to say sorry to the viewers, and I am unable to reply to this question. Thank you. Thank you so much. We are really grateful to the audience who have sent us these questions. Thank you for the opportunity to answer these questions, to ask these questions to Andrey Kazantsev. Thank you for everyone's participation. Thank you to the participants of ALLATRA International Public Movement.
Thank you very much, Andrey, for you being frank and for just being lively. And I really enjoyed our conversation today.
Thank you. I enjoyed it a lot as well.
And now we would like to present you with a beautiful book, АЛЛАТРА.
Онлайн-подарки вы получали?
Right?
Вот. И доклад.
А также хотели доклад.
And we would also like to present you with this ALLATRA physics report. We will send it to you via email, and probably we will send it to you in the printed form, our participants from Moscow.
The book АЛЛАТРА and АЛЛАТRA physics report, they have inspired us for different activities, and we are sharing this information with the whole world.
Она относится уже к
And the information that is presented there is among the top topics that we have touched upon here today.
Спасибо всем огромное.
Thank you. Thank you so much. Goodbye.
До новых встреч.
До новых встреч.
See you
Thank
soon.
you.
Thank you so much.